Hey juniors, today we want to talk about how to find the equilibrium constant. And so we're going to solve a sample problem that is in your text on page 558. And in this problem, we're going to be given the amounts of each our hydrogen and our iodine gases to begin with. And if we know that 1 mole of colorless hydrogen gas and 1 mole of violet iodine vapor are sealed in a 1-liter flask, and they're allowed to react at 450 degrees Celsius. At equilibrium, we have 1.56 moles of hydrogen iodide, and together we have some of the hydrogen gas and iodine gas left. Let's calculate for the equilibrium constant for this reaction. So I went ahead and wrote up the initial amounts of my reactants on the board, and I also wrote up the concentration of my product, hydrogen iodine. I have 1.56 moles at equilibrium. And so in order for me to solve for the equilibrium constant, I know that this is just a ratio of the concentrations of my product to the concentrations of my reactant. Now I know how much hydrogen iodine I formed at equilibrium. I know that's 1.56 moles, and I know I'm going to square this because if I look up in my equation, I have 2 moles of hydrogen iodide for every one of each of the reactants, so I know I'm going to square that. What I don't know are my concentrations of hydrogen and iodine at equilibrium, and I need to find those before I can find my equilibrium constant. So let's go ahead and talk about what we do know. We do know, shift that over just a little bit, let's look on the side of the board. We do know that at equilibrium, the amount of hydrogen that I have and the amount of iodine that I have are going to be the same. Because if I look up in my equation, the ratio is the same. And I know that I'm going to produce 1.56 moles of hydrogen iodine. So that means half of this is going to come from hydrogen and half of it's going to come from iodine. So 1/2, so 0.78 moles of each are going to be used. Now as I look down here, I want to find out how much I have left at equilibrium. So that's the amount of gas that's not used. If I start with 1 mole of hydrogen gas and I use 0.78 moles of hydrogen gas in my reaction, I have to use 0.78 moles of each are used up. That means the concentration that I'm left with is 0.22 moles of each hydrogen and iodine. So now this is what I know. I know my hydrogen ion concentration left is 0.22 moles per liter, and I know my iodine concentration left is also 0.22 moles per liter. Now I'm ready to plug these values into my equilibrium equation. So now what I can do, I can take my 1.56 moles of hydrogen iodine squared, and I can divide that by my 0.22 moles remaining of hydrogen and my 0.22 moles remaining of iodine. The important thing to remember is this is what exists at equilibrium. It's not how much hydrogen I used, it's how much hydrogen and iodine I have remaining at equilibrium. So I had to take the amount that I started with and I subtracted the amount that I used to find out the concentration of both hydrogen and iodine that I have remaining. And then when I plug that into my calculator, I get an answer of 50. 50, which is much greater than 1, so I definitely know this is This is very much a forward favored reaction. Let me go back up so you can see that equation to begin with. Because my equilibrium constant, my KEQ, is 50, it's greater than 1, and so this reaction is going to favor the forward and be just slightly reversible. I hope that this helps you. Zoom out just a little bit so I don't scare you. I hope this helps you as you're doing your homework, and you can come back and look at this problem on page 558 and understand how to solve it. Again, this was how to solve for the equilibrium constant when we were just given the amount of product produced. And then we had to go in and calculate how much of each, the concentration of the reactants that's left over. So you can refer back to this video when you're doing your homework assignments. Good luck.